Welcome to Did You Know? The ESCO HVAC Show. We will see you in about 45 seconds or so. Make sure that you are subscribing to our channels, our LinkedIn, YouTube, Facebook. Turn on notifications, and we are very excited to be here with you. It's almost time, about 30 more seconds. Make sure to grab your notebook and pen so you can jot down notes along the way, because at the end of the show, you could have an opportunity to ask our guests questions so we can dive a little deeper into these topics. And here we go. Welcome to Did You Know? The ESCO HVAC Show. Well, welcome everyone to Did You Know? The ESCO HVAC Show. I have a question for you. This is a question that was brought up to me that I had to ponder for a little bit and really start questioning my own understanding of electric resistant heat and heating elements and electric heating just in general. So one of the notions in the industry is that electric heat is 100% efficient when we're talking about, say, electric furnaces. I've never questioned that until recently. Until I had the chance to sit down with Alan Coggins of Cocoon, and we had a really good discussion on electric resistive heating, and he made a comment that I had to ponder and actually ponder for hours. The notion of electric heat and electric resistive heating elements being 100% efficient is false. And it's actually theoretically impossible. If we look at electric heating elements, an electric resistive heating element, what we're looking at is how much heat we're converting from the electricity that we're using. And the general theory, the general philosophy is that we use 1 watt of electricity converted to 1 watt of heat, about 3.412 BTUs per watt, right? And that electric heating element should be 100% efficient. So for every watt of electricity, we are producing a watt of heat. Well, let's think about that for a second. There is an immediate byproduct of that process that I had almost completely forgot about, and that was the illumination factor, that we are converting electricity into luminescent energy. And if we look at how much energy that has, we're talking about 12.5 lumens per watt of electricity. So if we have any lumens coming off from a heating element at all, we've immediately left the potential for being 100% efficient. I never thought about that. And we can dive much deeper than that and look at how much heat we're actually losing off from an electric furnace in other applications. As we start looking at electric replacement heating sources, as we are starting to remove carbonized heating sources from our environments to reduce our carbon emissions, we're going to be looking for our most efficient electric heat sources. So we're going to be looking at factors that provide the highest amount of heat per watt of electricity that we consume. One of the factors that we look at all the time in the heat pump applications is COP, coefficient of performance. And essentially we're looking at the same type of a standard. For every watt of electricity that I use, how many watts of heat can I produce? Now, what we have to look at is alternative electric resistive heating options. And today we're going to dive into a very fascinating idea that has now came into fruition as a component, as a piece of equipment that is not really it's not really offered as options in the industry. And Alan, I really am excited to talk about thermal mass today, and we appreciate you being here on the program. So let's learn a little bit more about thermal mass heating and educate the industry from perspectives that may not have been noticed before.
Yeah, Cliff, thank you for having me on. Really enjoy being here and looking forward to this too. You know, just to kind of give a little background about myself, I carry 2 journeyman cards under my belt. I went through sheet metal workers, both their service and sheet metal apprenticeship. And then I got into testing and balancing. And that's what really got me thinking like an engineer,
Yes.
and how things work. The engineer would design it, and the sheet metal guys would put it in, and then I'd come out and make it work right sometimes. Or
Yep.
everything looks great on paper until you put it in, until you
Right.
implement it right.
Application.
That's right. And so I learned a lot, of different ways of how energy is moved, and everything with balancing, of course, throughout the career. And so I've always been the tinkerer in the basement, if you will. Or
Oh yeah.
my wife says I just like to blow stuff up, but that's the
At least tear it
difference.
apart, see what it's made out of.
There you go. Difference between men and boys, right? The
That's
size of the
it.
toys. So it's but yeah, and then it really came into more than that. I had the aha moment. This is actually my second energy invention I have brought to
That's
market.
right.
I created the nation's first hybrid LED street light. So I brought all the LED lights you see on the roadway today. I'm the guy that kicked that off in the country.
Love it.
I just didn't sell that patent for enough money. Otherwise, I'd be in St. Croix instead of St. Louis, or
That's right.
someplace with warm and sunny beaches anyway. But mildly joking there. But so yeah, and I've really had, all throughout my apprenticeships and everything, we were always told the HVAC guys are the most experienced and the most trained in the industry. And I thought, well, let's put it to work and let's see. And it's
Right.
really true when you stop to think about it. We've got to know a little bit about every trade, right?
Yeah.
We've got geometry, cutting, physics, chemistry.
Chemistry.
The list goes on and on and on. And so I've always had that passion, if you will, to create. And I started on this project, on the heating project, close to about 11 or 12 years ago now. And first it was part-time, and then it became more than part-time, and then now
Big
it's
hobby.
full-time. That's right.
Yeah.
And now we're selling furnaces all around the world. We've
Good.
got furnaces in Italy, England, Newfoundland, the East Coast, here in Missouri. We're heading to a lot more places across the globe.
Oh, I know you will.
The energy crunch that's happening and everything right now has been really good. To help get the product and get the technology out there. And we're not just in residential heating and cooling. We're in industrial and commercial, and so we've really tried to take the technology and expand it all across the HVAC industry, not just one portion of the industry. Yeah.
Sure.
So, but yeah, I'm really looking forward to talking with you guys today and just really explaining the differences and talking about the differences in what our equipment is, how it works, and what it's good for. We are a direct replacement for any HVAC or for any furnace out there, if you will. We have many different models and sizes, and we offer some solutions that our competitors do not. And I myself used to be a service tech and engineer, or service tech and installer for many years. And, I experienced a lot of the things that I hated, I got to live it firsthand, carrying heavy furnaces up and down stairs or in attics and, all that stuff. And, just try to create something that, is safer for the installers and technicians, something that is easier and quicker to work on. Because let's face it, you get into somebody's home, people don't want you in their home, right? They want you in and out of there, and you can't take. I remember the days of a heat exchanger being an 8-hour change out, and that person had to take off work and be home all day, and we're nowhere near like any of that stuff. So all the stuff that I did not like, I tried to design out of my equipment.
Yeah, your own experiences.
Yep.
Sure.
So, if I can, I'll go ahead and kind of share the presentation here and get started.
Yeah, absolutely.
All right, here we go. Gotta love and hate technology all at the same time. So, what is Cocoon, right? And how does it work? How do we install it? And again, I wanted to touch on some of these other things, like where we're being put into the industry and different aspects of the industry that we're at. And in this, Cliff, we'll send this to you. If you go to our website and on our resources page, we've got a documentary there that we shot with PBS in 2020.
Yep.
And
Seen that.
you can check all that out. Yep.
It's very interesting.
Thank you. Thank you. So Cocoon, we're the first revolution in heating in over 100 years. Let's face it, an electric furnace has not changed. Everybody's
Electric heat's electric heat,
yep,
electric
and
heat.
they've been selling the same thing. Everybody's building the same exact thing, a toaster with a blower on it, right?
That's it.
And that's pretty much it. And, we're trying to, I like to tell people we are a path to energy independence, and, we are trying to eliminate the reliance on fossil fuels.
Sure.
We get those gas-like temperatures without all the kaboom and, without all the issues here. And this picture that you see here on the right is actually a shipping container that I'm running 100% off grid, and we run a furnace and some camera systems and that kind of stuff. But,
sure.
we do some different testing and stuff like that in there. And then the other thing I wanted to mention too is that, we were verified by Underwriter Laboratories in 2018, 2019 that we use up to 41% less electricity to produce heat
than a standard electric furnace, which is pretty crazy.
That's right. Yeah. And so how does it work? It's
big question.
Call it, 4 to 5 key different elements. I mean, there's a lot more than that, but these are the ones that we can really touch on. And the thermal mass, it's a big hot rock, right? Inside of the furnace. It's not the toaster. The infrared heat, and I'll go over that in more detail. Like, where do we, what is our furnace doing? Where does it line up in the infrared spectrum, and what kind of heat is it producing?
Sure.
The modular and scalability with the special design features. We do have a 0 clearance install rating. We still recommend 1 inch around everything. It's just good common sense.
Yeah.
And then, of course, our controls and our control algorithms. What do we do with our controls and the control algorithms? Because of the thermal mass, we're able to offer some control aspects that you're not going to get with conventional equipment. So the thermal mass, what you're seeing here on the right-hand side is the inside of our furnace. You're getting a look under the hood here. So the big black portions that you see inside of there are heating panels. And there is 4 inside the heating 4 inside of each heating chamber. And where the screen mesh is, there's a heating panel underneath that as well. So you can see you got panel 1, 2, 3, and 4. Now, this is very directional heat. Okay, so an open coil is going to throw that heat in a 360-degree radius, right? And we are trying to control that heat and control that energy and put it where we want it, which is right where that air is.
Right. Not in the insulation.
Exactly, not in the insulation. Yeah. And so, once you have that thermal mass heated up, you can do, you can basically, you don't need the same amount of energy in order to keep that thermal mass hot. If you want to maintain a steady state, then yeah, you got to constantly dump energy into it. So one of the things that we do is we play upon the characteristics of the thermal mass, and you get a nice, more gradual curve than you do peaks and valleys when it comes to comfort and it comes to energy usage as well.
Okay.
We'll discuss that here in a second. So the infrared aspect. In the lower left here, you see that we have an open coil. When they run, they do produce light. And when we run, we do not produce any light. And so all light, if it's on a visible spectrum, is going to be just above the shortwave or a shortwave infrared spectrum of light.
Okay.
When our furnace runs, we're running a medium to long wave. So we're not producing light. So therefore, we're already saving energy when it comes to that. And kind of when I was talking about the curve aspect, you can kind of see here, even on the bottom of that chart in the upper right corner there, that as you get down into infrared, medium, long wave, microwave, so on and so forth, your curve becomes less of a peak and valley. And so we really see this in our energy when we capture the energy reports on the furnace. We really see that it's even much more spread out than that when you start to talk about how the furnace is affecting the home, and what does that comfort look like. The modular and scalability, again, being an installer, and we need solutions, right?
Exactly.
You've got a low ceiling height, and you need to put it in a different way, or whatever the case is. And we just have more capability and more solutions for an install than what you would find with conventional equipment. The other thing too is that when you turn around and let's say you need more heat for that building, let's say you had a sales guy who undersized the system, and I'm going to pick on them because I've had it happen in my career.
What?
Yeah, imagine that. Sales guy undersized the equipment. Well, okay, now we had to pull out that brand new furnace. We couldn't use it for anything else, and had to put in a complete brand new furnace. Well, with ours, if that happened, they can add another heating chamber. So I mean, it's very modular and scalable when it comes to that. And so,
Interesting.
what you're seeing here is, like on the pictures on the upper left there, on the left picture, that's a compact, and then we go into our 2000 model and then our 3000 model, and just to kind of show you some the different aspect of what we can do. In the 3000 models, we have those in greenhouses actually. This is a
Oh, sure,
yeah,
absolutely.
and this is a greenhouse in northern Missouri, and I think their coldest temperature they had was -10, and it was 72 degrees in that greenhouse.
No kidding.
Yeah.
Very,
Now,
very
granted,
cool.
wasn't a massive greenhouse, but you know
Sure.
what? An R it doesn't matter what you're heating. If it's an R3, it's like heating a shed, right?
Yeah.
So again, here's kind of the differences, in our different series, and just we can go from a compact size up to a larger size, so we can get into commercial and even industrial applications, depending on what we need to use or what they're looking for.
So you can go up to, is that, am I reading that 160,000 BTUs?
Correct. Yep.
Wow. Okay.
So the special design features.
Right.
In this, so what you're looking at in the middle picture there is our blower chamber, and we've got a nice little air gap that you can see in the left picture. That's our heating chamber. That same air gap is throughout that heating chamber as well. All of our heating chambers are a double wall construction. So
Sure.
the idea there is that in conventional systems right now they use insulation insulation does not recapture anything. It only slows the migration of heat, right?
Yeah, and then if you go into a uninsulated, unconditioned area, well, then it's significantly different.
Exactly. So what we try to do is we try to recapture the heat that would normally be escaping from our furnace. And let me show you this. Let me play this video here for you. What you're seeing is actually a mixed air temperature happening in our blower box. Again, like I said, I was a balancer, and we
Sure.
used to have to balance outside air systems all the time. In
Absolutely.
commercial, you got to bring in your outside air, fresh air. And so what this is doing is that the heat that normally would have been escaping outside of the jacket of the furnace is now we're recapturing and bringing back into the airstream and trying to put it back into the home.
Hmm.
And
So
so
reutilizing as much of that heat on that exterior portion of the cabinet as possible.
absolutely. Now, of course, there still is heat that's going to migrate out of the
Right.
cabinet. It's just we're trying to to capture
Minimize that
everything that we
potential
can.
loss.
Yep, yep. And so anything inside of that cabinet, is going to be under a negative pressure, of course, and we're trying to to recapture that heat. Our controls and our control algorithm. So what you're looking at here is the brain to our furnace. This is a Mediacon M172. It's a smart relay. Think of it as a miniature computer inside of a furnace. That was one of the other things that I didn't like about conventional equipment is that I would get this furnace, it had a control board, and your settings were very minimal what you could do to commission the furnace to run the best that it could inside of that customer's home or business.
Yeah, absolutely.
And so with this, once we start capturing the data, in which we do data log with this, we can then start to customize how the furnace runs to that home. Now, of course, you're not going to want to make a change like that, until you got at least a good year and a
Some
half to
baseline.
2 years worth of data. Right.
Sure.
Absolutely. And kind of what you're seeing here is that, what we're seeing is that we can capture, okay, the runtime, basically the duty cycles when you get right down to it. And also, the controller is great for BMS systems. It's got a Cat5 connection there and speaks BACnet and a lot of the other, I think one or two other the BMS protocols as
Communicating
well.
networks.
Yep.
Which we're going to see a lot more of. As we start looking at higher efficiency ratings of systems, we have to do more monitoring and we have to have more compatibility with networking and controls, because we're going to see a variety of different controls coming into the residential market, doing more of the automations of systems. So having capabilities of, communicating right off the bat is a pretty important, step forward in planning for home automation.
Well, absolutely. And if you look at it this way, like, okay, we get a conventional furnace, and it gets put in there, and I'm just going to pick on gas here, and you're going to have a low fire and a high fire, and that's it. Okay.
Hmm.
You know, with our system and with this controller or these types of controls, I should say, we're now going to be able to say, okay, instead of running 4 panels, let's run 2, let's run 1. So we're going to take that staging, if you will, to a whole nother level. Because again, we're writing the software to be, learning, to just
Sure.
learn what's happening and to be able to, if that customer gets new windows or more insulation in the home, they've just changed the whole profile of the house or the envelope of the house, if you will.
Absolutely. And
And
one of the trends that I've seen in the industry, which I really struggle with, is I've seen electric furnace manufacturers that are bringing on all banks of electric resistive heating when it calls for the auxiliary heat. There was a time, it's been couple decades ago, where the HVAC technician would design how to stage in the electric heat and determine how much heat was needed for defrost cycles, and that has since went away. So a lot of our electric furnaces are slamming on every bit, 100% of the electric heat, instead of doing controlled staging, which is what we're talking about. We're looking at
right.
the demand of the system. So not only are we looking at a change in efficiency off from the heating mass itself, now we can start looking at, well, let's modulate in and stage in multiple layers of heating sequences to try to minimize that amount of electrical consumption.
And Cliff, that, I mean, from the technology difference, right? UL, when we did that testing with them, was, here's your difference, your
Yeah,
41% differential. And to me, we're just scratching the surface. That's the start,
sure.
because when we really look at that, and now you have more options with your furnace in that customer's home, you have more things to do with it, or you can do with it, I should say, is really going to affect that customer's energy consumption over the life of the equipment.
Yeah, absolutely.
So to kind of just explain the controller here a little bit, we have this is a 24-volt controller. I just tried to show that, hey, we have different fan speeds, of course. We have a speed for normal heat operation, and then of course, our duty cycle is a little different. We don't just start and stop. Because once you have that thermal mass heated up, you have all that energy stored there. So we then, you know, when the thermostat's satisfied, we then lower the blower speed and run that for a given amount of time, anywhere from 10 to 20 minutes longer. And we're not overshooting the thermostat in the house, because what happens is you're putting those BTUs that we have captured in a more efficient manner, and then now we're utilizing them on the back end, if you will. I mean, the whole thing, right? Energy cannot be created nor destroyed. It only changes from
Right.
one form to another. And in our application, either it's going into the thermal mass to be used down the back end, or it's going into the air immediately. And unlike a conventional electric furnace, it's on or off. That's all you get. You know.
Yeah.
And so what we're seeing is that our energy curves start to really look like like rolling hills instead of peaks and valleys.
Yeah.
And so I'm going to play this video here real quick for you. This is a minute video, and just kind of give you a quick tutorial on how to navigate our controller.
This is going to be a quick tutorial of the menu options on our Mediacon M172 and the Cocoon furnaces. If you click OK, it'll give you a light, backlight. You're going to click the right arrow button to scroll over to any new menu. And at this point, this is your landing page. This gives you basically your I/O statuses, your set points, the data logging, clock, how to set the SD card and the memory card. We'll go through that in another video later. And then actually, this here is for USB, to where you could plug in a USB up here and download your data files into your USB without having to remove your data card. So if you want to back out of any menu, you're going to hold the left arrow button down for about 1 second. And it'll take you back to the menu from there.
It's a pretty straightforward controller
Here
for
is
the advancements that we have.
memory card available or memory card inside of there. It's just a quick way that you can look at it and say, okay, does it have one in there or not? Because since they're micro, they're kind of hard to see.
just kind of a quick, rundown. I tried to make it as simple as possible.
Thank you.
With your IO statuses, your input output, what's happening? Do we have a call for heat? Do we, is the fan on? Is the fan proving switch on? Those things that, normally you're, pulling out your meter to check. A couple of things you can just check right through the controller.
Yeah, absolutely. I'm a big fan of using, quality controllers. You get so many diagnostics and capabilities that you can run through, an automated controller.
Yeah, and they're great. I mean, I see this being the wave of the HVAC industry, even for residential, and getting away from the on-off boards, if you will.
Sure. Alan, one of the questions that popped up is the AA, or is there, excuse me, are there AHRI ratings for your equipment yet?
Not yet. So, actually, it's funny because there are no AHRI ratings for air handlers, and technically we are. Blower. Yeah, technically we're still, labeled as an air handler. Now, of course, we're working with DOE at the federal level right now and trying to show that, hey, look, there is a difference, and that yes, that we are a different animal. You ask a fish to climb a tree, you're going to get that kind of result. So.
Absolutely. And that's one of the questions that have been brought up, when you do equipment matching, verifying what your, system capability is. And it really is going to depend on the heat pump or, whatever outdoor unit that we're matching with. Because in the past, all of our electric furnaces have been compared equally to each other. So right. it didn't have a significant difference in matchups. Blowers was really what made the significant difference.
Absolutely. And I sometimes I try to tell people, if you think about it, think about like when two-stage gas valves came out, right? That was a whole nother, level of a gas furnace, if you will. And that's kind of what we have done here, is that we have made a whole nother level of furnace. I don't like to call us an electric furnace. We use electric as our power source. Exactly. That's it. Because of our low energy consumption, I run these off grid. I can hook them to a battery system and not even hook into the grid.
Wow.
All different types of things like that. But,
sure.
This is one other thing I wanted to touch on too, is the controls and the components that are inside of there, is that these are terminal blocks. Now you're going to see these in the industrial sector of HVAC, but you really don't see them in residential.
No, hardly at all.
Here's why the residential technicians are going to love this. Is because there's no more tightening screws. Okay. Yeah. If we had that big block up there in the middle picture where you see all the terminal blocks at, if all of that was screw terminals, you'd have to go in and tighten, 70 different screws. Not to mention, we would see that they would come loose in shipping,
sure.
So, this right here eliminates that immediately. They're quick, they're easy. And they're identifiable, very, very identifiable. All right. So the installation of our furnace, our furnace is the installation is kind of a hybrid between a gas system and an electrical system.
Sure.
Gas system, as you can cut the side of the blower out. Most electric furnaces, conventional electric furnaces, you are not doing that with. We do not pan the bottom off. Our bottom is open. So if you do cut the side out, then we're saying, hey, pan up the bottom. Don't pull in that basement air or attic air or whatever the case is. Or if you don't want to cut the sides out, you can stick them on a box and, put them up. And if you look at this picture on the right here, I just wanted to bring this up, is that, this was an install that was done by a contractor down in the Lake of the Ozarks. And, this picture has had more trolls, I'll say, get on there and, oh, that looks like crap. He didn't do this right, blah, 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 blah. The point that we wanted to make is that don't tear your fellow technicians down, build them up. Don't tell them it just looks like crap. If you see an issue, right, we're all here to learn and improve, is to really just help your fellow technicians. And you never know when you're on a job, there might be a reason he had to do something this way, the boss is yelling at you, or you didn't have the height, or whatever the case is.
Sure.
It's just so funny to me how, you put stuff out there and people immediately want to tear it down instead of, trying to,
sure.
Give some constructive criticism.
Well, and I do enjoy the flexibility with the cabinets. There are a lot of
Yeah.
applications where conventional installation is limited, so it gives you a little bit more opportunity with your design.
Right.
Alan, we've got a few questions, if I can just throw them out at you.
Yeah, sure. I was going to say, I can't see you guys right now because of sharing the screen.
No, that's
Sure.
okay. So one of the questions is, for innovative systems like this to grow their market share, we're going to need a larger pool of qualified technicians to install, service, and maintain them. What are you doing for an educational outreach? Are you working with schools?
Absolutely. So we're trying to get in as many schools as we can. Sheet Metal Workers Local 36 here in St. Louis has our furnace in their training facility. Jefferson College, East Central College, and we have another college out in Indiana who has our furnace out there too. And I'm going to actually get into this because that was one of the things I really wanted to do with the design of the furnace is I wanted to keep it simple, stupid, right? Kiss it.
Right.
And, if you have a first year apprentice or a first year technician out there and he can read a wiring schematic, there is no reason why he cannot work on our furnace.
Sure.
And I'm going to show you a picture of the controls and just the guts of the furnace as well and how easy I've tried to make it.
Yeah.
I remember the days of the old heat pumps and the old electric furnaces that, you open it up and it's a rat's nest.
Sure.
I mean, no wire coloring, coating, or anything else. But, I'm going to show you that here in a second.
Yeah, absolutely.
I hope that helped there, Howard. But,
Yeah, we're getting some questions in. I teach at a school. Where can I get your furnace to teach my students, for example?
Yeah, call us, come to us because we have, we are making special concessions for schools. I look at it this way, that is our grassroots movement, if you will.
It is.
Anytime I go out and I talk to students, even high school students and everything, that are looking to get into the trade, I tell them, go back and talk to your contractor that you're working for and tell them about this and how simple and easy it is. And so, yeah, definitely give us a call. And we do. I want to be in every school in the United States if we can.
Yeah, absolutely.
The technology is not just about our own furnace as well. So recently we've just partnered up with Unico, high velocity system. And, each market, kind of has its own little different segment, if you will. High velocity, you're going to find, that they've got, they're in a lot of homes on the East Coast and, over in Europe, any place that had boiler heating. Well, they needed air conditioning. They didn't have conventional ductwork.
Sure.
Or they didn't have the space to put in conventional ductwork. So the high velocity works well. But when you start looking at high velocity and let's say you need a 20 kW, furnace, well, your pressure drop, they're fitting, 10 pounds of crap in a 5-pound bucket, right?
Right.
And the pressure drop across them is great. I mean, it's massive.
Very significant.
Exactly. And so we offer a better heating solution when it comes to high velocity systems.
Which is really cool. I used to service quite a few of them back in the early residential days. And, as many technicians that have encountered high velocity systems realize that there's not a lot of options when it comes into replacement heating sources. So
That's right.
Very interesting add-on component.
Well, and let me just say something here too, because, like the picture on the right here, this is, one of ours, if you will. And yes, the filter is installed, the air is coming down through the red furnace, through the air filter, and then back up. So yes, the furnace is before the air filter. We did that on purpose. What we have done is that we, in some of these installations and some of these pictures, we have tried to install them and break them any way that we
improperly,
can.
Right.
Exactly. I mean, that's what it's really come down to. Not just sales and all that other stuff. Now it's like, ooh, how can we break it? And I got to say that's a lot of fun.
Yeah, absolutely. One of the questions that came in, and it does bring up an interesting point, are these dedicated to be installed when we're talking about the heating source on the negative side of the blower or on the positive side of the blower?
You can do either. And that's the beauty. If you look at an open coil system, let me go back to that slide. Sorry, guys. Here we go. If you go back to that open coil system, right, if you lose your airflow on that, you're going to burn that out immediately.
Exactly.
With ours, you could technically, now I don't recommend this, but you could run it like a gravity furnace. and let gravity take its course. I mean, you can run these panels all day long with no heat on them. Now, of course, we don't recommend that.
No air.
Yeah, I'm sorry, no air on them. But
Sure.
and that's one of the differences too. That I wanted to build something very just rough and rugged. Drag it through the mud and it still works, kind of thing.
Exactly.
Let me scroll back through here. Okay, and then kind of like where do we fit within the marketplace, right? A lot of people have been telling me, that heat pump, heat pump. I think everybody's heat pump stupid right now.
Right.
It's the greatest thing since sliced bread. However, your heat pump starts to lose capacity after X amount of temperature.
Absolutely.
Okay, and once you start losing that capacity, then it makes sense to shut it off. Don't throw good money after bad money, right? And utilize our furnace, and then you're getting the best of both worlds. So really, when you start pairing us with heat pumps, and we have real world testing data that will show this as well, that we can actually rival the operating cost of geothermal. We're not beating it by any means.
Sure.
But where we do beat geothermal is our installation cost, a much better installation cost. So we have actually been beating out geo quite a bit, here lately, as far as people looking at installing geo, or they're looking at installing our source, our furnace with a high efficient heat pump.
Yeah, which brings up a really interesting thought is, now that we're talking about the heating solution, we've seen some photos of the Cocoon equipment, matched with certain types of outdoor units. Is it specifically matched to your equipment, or is it compatible with other options?
Yeah, so we've got, we've matched pretty much with just about everybody's condenser or coil. It doesn't matter, name a name brand. I've tried to hit all the major ones. And I say matched, you can use our furnace with their, A coil and condensing unit. Now, of course, we want to know what are they running at, meaning, are they running at 400 CFM per ton, or are they running at 350 to get better dehumidification?
Sure.
Or like in the high velocity systems, some of those are running 250 per ton,
Sure.
when you get right down to it. So, so the benefits of the technology in itself are much greater than what you'll find against, I believe, gas or the conventional electric system. Again, being safer, the 100% efficient aspect. We're still dealing with DOE at that point to try to say, to really show the differences here.
Validation.
That, hey, yep, and just validate that but either way, we're the 100 plus if you get right down to it, but we're right at 100. But we don't have the carbon monoxide, the flammable gas, all those things, the programmable controller. I think the benefits far outweigh any of the other issues that you see with conventional equipment. Not to mention, we can be powered by greener technologies, because of the low energy consumption, and you can utilize solar and wind with this system without having to triple your battery storage because of how much that the conventional systems utilize.
Yeah, because that is one thing that we have to look at is, the amount of inrush of current on electric resistive systems.
Yep.
So, it gives us the ability now to slow that down and stage that a little bit easier.
Absolutely. Again, we're made in the USA. This is kind of geared towards our contractors, of course, that they're going to see better margins. We are the Tesla of the industry. Tesla, Elon Musk, he was talking about, he wants to get in the HVAC industry, and he wanted to create something modular. Well, we've beat him to the point here with it. And, I'd love to get paired up with, the Tesla walls and everything else, but, we haven't had an opportunity to do that yet. So,
Sure.
But yeah.
You've definitely made a break from the norm, which is the most interesting aspect. Because when we look about, electric resistive heating, how long have we used it? 100 years.
Yeah.
And how many times have we changed that in 100 years?
0.
We've changed some sequencers, and that's really about it. The way that we stage them in has been the only thing. Materials haven't changed much. The insulation hasn't changed much. So it's a market that's definitely been due for some updating.
Let's see, there we go. Okay, so there, that last slide there was some testimonials from our distributor in Newfoundland, HVAC Specialties. Like I said, we've got some furnaces in some very cold climates.
Right.
This type of technology, my goal is to put a furnace on the moon. And, why would you want to put something like this in there? And actually, I'm going to share another picture here with you.
Yeah, absolutely.
In
Please
just
do.
1 second. Why would you want to put something like this in there or on the moon or in any sort of case? And I also think this technology could be utilized to help, get to the other planets and stay there. Because of that thermal mass, we are doing a better transfer of energy than what the typical electric furnace is doing. And we see that. And how do you measure that? You measure that not only in energy consumptions but also in comfort levels too. Because let's face it, you've got customers out there that they don't care what it costs, keep me comfortable.
Yeah,
or
absolutely.
you have the other customers who are, no, I'd rather sit here and and be a little uncomfortable but save the money. So.
The design of thermal mass has been an object of construction for decades. We look at construction materials and their ability to store energy and to store thermal conductivity as a way to create and control the comfort of an environment. So it just makes
Right.
sense that we utilize the technology with air flowing across it to do the same effect, to be able to control the heat load from a slightly different aspect ratio.
Well, and you can kind of think about the in-floor systems too. I mean, you're heating up a large thermal mass, and what happens? You get a nice, more comfortable, even heat. The same thing is holding true with our equipment. Let me show this picture here.
Sure.
So this is the guts of our furnace.
Okay.
Can you see that?
Yep, got it up for you.
Okay. So again, as I said, keep it simple, stupid, kiss it. 101 right here. Yes, your high voltage, you're coming through the fuses, in through the contactors, and then, out through the distribution blocks, or the terminal blocks. We've numbered all the terminal blocks. We've tried to color code wires as, and make things different as best you could. And that's why I say that if you had a first year apprentice and he can read a wiring schematic, there is no reason why he cannot work on this. Where I think some of the technicians or even some of the students start to get, oh man, what is that? Is it comes down to the controller. But, this controller is no different than any other control board out there. And what I mean by that is that if you got power coming into it and no power going out of your proper terminal, well, you might have an issue with the board, right? I mean, that's how I was always taught, to troubleshoot boards. Power coming in, no power going out, you got a problem with the board. The difference is with these controllers is that to verify that it's not a programming issue, you plug a USB stick in with our program, cycle power, it uploads the program right to it. And if you still have the same issue, then immediately that, okay, you've got a hardware issue, not a software issue. Otherwise, everything else is electricity 101.
Now, for the download, so like your firmware, is that something that can be downloaded just through a website that can be put onto a thumb drive and taken to a location?
We are getting there with that.
Okay.
So, so we are getting there. Did that picture leave? Share
Yes,
stop?
it did.
Okay, all right, great. Sorry. So yeah, absolutely. We're getting there to where you can log on to our website. We're in the process of changing some of the issues on our website to where it's a contractor resource to where he could log in, download it to his own USB stick.
Oh, nice.
Right now, when the contractor, or distributor signs up with us, of course they get access to that, and we send the USB sticks out, at that point, but with our program on it.
Gotcha.
But as we start to continue to develop the technology, and of course, continue to input, new latest and greatest program, if you will, that's going to be hopefully just over the air thing, if you will, or over a VPN access, that kind of stuff.
Excellent. Do you want to show and share any resources where they can follow up with Cocoon?
Yeah, absolutely. Our best bet is to log onto our website, which is cocoonrevolution.com, and go to our contact us page, or if you're a contractor or a distributor and you're interested in carrying the product or selling the product, sign up on there, and then we'll have our team get a hold of you, of course, and go from there with it.
Yeah, absolutely. All right. Well, let's take a little second here and see if we have any other questions from the audience that we want to dive into a little bit deeper. Howard, you got anything that you'd like to question while we've got Alan with us?
I see more questions online than we could possibly answer in the next hour or so.
Yeah.
Yeah, well, let's dig into them.
Yeah.
I'll make this one a simple one that might help a lot of people. Alan, you're going to be at the National HVAC Education Conference. You're a presenter.
Yes.
Can you talk a little bit about what you're presenting? Because this is obviously going to be an opportunity for people to meet with you, ask firsthand questions.
Yeah, absolutely. So, we're of course going to be going over the technology and the differences, and why you want to implement this technology or these solutions into their portfolio. I say we're a direct replacement for any furnace out there, but the realistic part of it is, okay, we might be 99.9% of every furnace out there, but it just kind of comes down to at the conference of us showing the differences between what we do, how we do it, and kind of go from there with it. I am looking at bringing some display systems or something along those lines with me. I'm still working on that right now, and luckily I've still got some time to get that figured out.
Sure.
If schools are interested in working with you, is it best that they call you, email you, hit your website? What's your preferred way of connecting with everybody?
Yeah, I would say go to our website, fill out the distributor or contact us page, and just let us know that you're a school. Because again, we're making concessions there. We want the furnaces in the schools. We want to show that there is a difference in the technology, not just talk about it, but show it. And I think we've had more success that way, where we've had the students working on the systems, and they come up with something, or it totally, creates a whole new question, with the schools that we are in right now. So absolutely, just reach out to us and let us know you're a school, and we're going to take care of you.
Okay. Well, what do you think? I think it's a good wrap for a show. Alan, we really want to thank you for being here. There's a variety of other questions. I think that we'll grab some of these and do some follow-up with those, because there's quite a few topics that I think people probably should have an opportunity to get a hold of you. And so anyone that wants to make some contact with Alan, you're welcome to get a hold of Alan directly. You can get a hold of me at cbeck@escogroup.org. We can help make those connections for you. And man, we really appreciate everyone joining us today. Alan, we thank you for bringing us into a little bit of enlightenment on thermal mass heating and how we now have the potential to look past electric resistive heating in electric furnaces and have solutions that have higher energy ratings than some of the systems that we have been associated with in the past. So thank you all very much for joining us. And
thank you.
Yeah, thank you for having me. I really enjoyed it. And if you guys want to dig into any questions too, that just send them over, or we can whenever. I'm good. We'll make it happen.
All right. Well, we thank you all for joining us, and we look forward to seeing you next week on Did You Know, the ESCO HVAC show.
Thank you, guys.
Thank you for joining Did You Know, the ESCO HVAC show. You want to see some of these great presenters in person? Well, then we'll see you at the National HVACR Educators Conference, where many of these guests will be presenting live classrooms, and you'll have a chance to interact with them. Would you like to watch this show again? Hey, no problem. Just head on over to YouTube to ESCO Institute. Do you have a topic that needs clarified about some kind of a change in the industry? Well, then let me know. cbeck@escogroup.org, and we'll see what we can come up with.